Hello everyone, in this video I'd like to talk about how can we do the TCP/IP communication by using Siemens S7-1200 PLC and S7-1500 PLC. And this is the second video talking about this TCP/IP communication. In the previous video, I talk about how can we use the T-send and the T-receive, this traditional way to implement the TCP/IP communication. As we discussed, while we are using T-send and T-receive, these two function blocks will occupy the communication port respectively. So if we have one device need to communicate and we like to send and receive running at the same time, so we need to prepare two ports, one TCP/IP port for the send, one TCP/IP port for the receive. This device need to provide two ports respectively for send and receive. However, if you have one case and you are communicating with one device and that device only provide one port for sending and receiving, how can we do that? Then we will talk about this topic in this video. From this library, it's called LCom. This function block is much easier than the function we talked before. If you are communicating with one device that only has one port for send and receive, if we use traditional way, this is a little bit complicated. But this LCom is much easier. Firstly, let's go to this support industry.siemens.com, this website, and let's search the ID number 1097805003. And this library actually includes a lot of important function block. Basically allows the Siemens 1500 and 1200 PLC can do TCP/IP, SNMP, MQTT, so many communication methods. And in this video, we will mainly talk about the TCP. You can also review the manual download here. You can see maybe for the OPC UA or for the MQTT, you can also review this manual. Okay, in this video, we will talk about LCom. So let's download this example program. In this video, I will use version 17 and I will use 1200 PLC and use my laptop running as TCP/IP server and use 1200 PLC running as TCP/IP client. Okay, let's download and let's go to the TI portal. After we download this file, let's unzip this and we will see this file is not a project, it's a library. So it's good time to show how can we import this library and how can we set up project, import this library. Okay, and let's unzip this and let's open the TI portal and import this library. And I will use TI portal version 17. Okay, after we create one project, let me add one CPU here. And my CPU is 1200 PLC. Okay. And while it's creating the CPU, so I also highly recommend you read the detail from this manual. And we can download here, this document. And firstly, I'd like to mention, to run this LCom library, if you are using 1200 PLC or 1500 PLC, you need to take care of the firmware. So the 1200 PLC need to be greater or equal to 4.4, and the 1500 PLC need to be greater or equal to version 2.0. You need to take care those firmware versions, okay? And this library only fit for the 1500 and 1200. S7-1200 cannot use this library. In the traditional way, S7-1200 has a traditional LCom library. Probably you can find from the Siemens website, but in this video, we will mainly talk about the 1200 PLC and the 1500 PLC LCom, this library. Okay. And also, I highly recommend you read the detail for those parameters. We definitely need to use the data type from the library. So you need to read the detail of those function blocks and the data type. Okay, so let's go back to the TI portal. Okay, so once we create the CPU, because it's a version 17, so we need to set up the basic security. Okay, I will allow full access. Okay, set up the CPU and I will set my CPU IP address. And my CPU IP address 192.168.1.174. Okay. And after this, we will go to program. Then we need to import the library we just download. Okay. So to import the library, let's go here and click this Open Global Library and find out the library we just unzipped. Okay, this is the library we just unzipped. It's at here. Okay, this ID number we just download and unzip this, and we will open this library. So we will see this is a library. It's not a TIA project. It's a library. So from library, so open this library. Open. All right, we open this library, and this library includes a lot. So we will see it includes LComs, MQTT, SNMP, something. So it includes a lot. But in this video, we will mainly focus on this LCom, and we can expand. And we will see the LCom here. This is the data type. Okay, this is the function block, and this is the data type. We will drag those to our project. So from here, firstly, we will drag the data type, the PLC data type. So we need this data type, LCom type configuration. So drag to here. And drag this type, diagnostics, drag to here. Okay, PLC data type. And then we will drag this function block under the program blocks. Okay. We drag this LCom. Okay. And then go to the OB1 where we can call this function block. Okay. So from here, we can call this function block at the second network, because network 1 I can program some command. So let's drag this LCom. So create one instant DB. Okay. Instant DB. Okay. Okay, after we call this function, so we will see we need some inputs and outputs, and we will leverage the data type at here. For example, the configuration here, it need a variable. The variable data type come from this type configuration. So if we open this type configuration, we will see it includes connection, sender, and some parameters at here. And from this type diagnostics, so we will see this type configuration, this type diagnostics includes a lot. So the inputs and output function block, we need to create another DB. So in that DB, we can create the variables. So this is a shared DB. Okay, create a DB. And the name we can call, this is the DB TCP IP. Okay, so here let's declare some variables. So if we separate it here, so this DB will create some variables that are used for this function block. So first one, that is enable. And second, this is send. Okay, bool. And then this is send data length and the read length. And here, if we recall this menu, if we scroll down and find this send data length and the read data length. So especially for this read length, so read length come from this device, right? Sometimes the length from that device sent to this controller is hard to predict. Maybe the length sometimes is 30 bytes, maybe 40 bytes. It's a dynamic. Great things from this function block, it can receive the dynamic message. So we only need to send the maxim. So the maxim, this is 6F hex number. Okay, so we can declare the length like this. So the send length, we can declare, so if we leave the mouse here, we will see this data type is a udent. So here we can declare it is send data length. Okay, udent. And the data length, this is the sending data length. So we can define, that depends on from this controller to that device or to a computer, how many data we need to send, right? So for example, we can send 100. Okay, we can define here 100. And for receive, that is a read data length. Okay, and this we can send a very large. For example, this is the FFF, or we can set the data is this. Okay, so for example, we can copy this, paste to here. Okay, this is receive. We allow this function block receive a maximum length. So, and it can receive the dynamic length. Okay, and then we need to configure this configuration. So this configuration, it need the date type come from here. So we can drag this to here. Then we can name this as the configuration. Okay, and next one is a send buffer, receive buffer, and the diagnostics. So let's firstly do this diagnostics. Drag this, and let's call this diagnostics. Okay, and send buffer and receive buffer. So send buffer, we can call this is send. We can name this is send buffer, and we can declare an array. And in this array, we can declare this array that's starting from the 100. That's starting from the 1, and we can declare 100. Okay, and the date type, that could be the byte. And the receive buffer, so actually we can define a very large buffer. So the large buffer allows this function block can receive very large data. So in this case, for testing purpose, I can define just a 100 bytes. Okay, so actually this we can set 100 here. So in real case, you can set a very large, but you just take care, it will take the memory. Okay, read buffer. So after we define this, we can drag this send here, enable, send a command, and send the data length, read the data length, configuration, and diagnostics, and send buffer, receive buffer. Read the buffer. Okay, and the right side, we will declare some variables, the same thing. So connected, this bool, sending. The reason why I declare the variable here is easy for us to monitor. And in the real case, you can use this variable feedback, the status, to do something else. For example, show the alarm, right? Or trigger some other program, or transfer data, update your buffer, something like that. So you can use this connected and sending this result to do something else. And the same thing for those. Okay. Okay, we declare those, and I can drag this, receive data length, BZ, arrow, and the status, and take care of the status. This is a word. Okay, we declare this, and once we power up the controller, once it start to run, we can manually turn on to stay this enable on. That means enable this function block. And once we trigger this send, it will send. And here I can leverage the CPU one internal bool. So let's take off this, and I can go to the CPU properties, and let's go to the system and the clock memory, and let's active here. So once we active here, we will see this 1 Hz, the 0.5 M0.5, it will run 1 Hz pulse. So that means every 1 second we will send a data. Okay, so if we are going to use this M0.5 as a send command, every 1 second it will send a data. Okay, so if we go back to the program. So we need to active there, then okay here. So we can firstly use this. So once we gotta enable, then we can use 0.5. Okay, this is the clock 1 Hz, and then this command will send to this send. Okay, this send. So once we enable this function block, it will use clock and trigger this send. Okay, and we will see it doesn't have the receive enable. This is the beauty of this function block. Once we enable, it keeps receiving the data. So once you have some data sent to this controller, so the controller will receive to this buffer, read buffer. Okay, and the port, it only use one port. Then the question where we can set a port. So let's go to this DB. And the configuration comes from this LCom type configuration. If we expand here, connection, then take care, because this configuration need to set a lot of parameter here. So take care, we need to enable this retain. So we can set some parameter here. And after this, if the controller cycle power, all those parameters still stay. Okay, interface ID, like I introduced, interface ID represent the hardware ID number. So for this case, I'm using this physical port to do the communication. Click this port, we go to the system constants. So we'll see this port ID number is 64, the same as the default. And if we go back, so here, the interface ID, that's a 64. Okay, that means we tell this function block, hey, I'm using this physical port to do the communication. And the connect ID is the same thing. So we can set number 1 if this is the first one. Second one, if we are communicating with different devices, make sure for different target, you are using different ID number. And for the different function block, make sure the ID number is unique. Okay. And for the detailed explanation for those input and the parameters, we better review the menu. Okay, if we scroll down to check this configuration, and we click this LCom type configuration, so we'll see what does it mean of those parameters. For example, for this COM service, it can set 1 or 2. So this need to be very carefully. Default, that's a 2. Default is it will run the LCom protocol. LCom, actually, this is one terminology from Siemens. It represents one special protocol behind. But in this case, we will leverage this function block, run TCP/IP. So we will now use the default number 2. We will change to 1. This need to be very carefully. Okay, so we will change to 1. And this CPU will run as a TCP/IP client. It will active to connect the server. Server side is my PC. So its client will set to true. Okay, active connection. And the connect type, we will set to 1. Okay, this is the IPv4. Okay, so let's set these 3 parameters at first. COM service will set to 1. So COM service will set to 1. Make sure we set to 1. This is very important. Its client, we need to set to true, because this will run as the client. Okay, it will run as a client. Okay, good things right side, it has common here. And the connect type, we will set 1, IPv4. Okay, so set 1. And the local port and the partner port. So local port is our PLC port. For example, in this case, I will set our PLC 3000. This is the PLC, this is CPU local port, TCP/IP port. And the partner port. So in this case, I will set my PC side, and that TCP/IP server software I will run as the server, TCP/IP server, and the port I will set 2000. Okay, and in the real case, you need to check your device or your target what the port is using. Okay, here this is the IP address of my target, and this is very clear. And here I can set the integer number 192 168.1. So my PC in this case, my PC is 253. So this is my TCP/IP server IP address. Okay, then let's check this partner QDN and those parameters. So we will see it's basically nothing, so we can ignore them. This accept unknown partner is only used for the passive connection. That means the PLC side will run as TCP/IP server. So usually we can select the false, only accept the configured connection. But in this case, we are running as a client, so we do not need this. And the lifetime cycle time, so we can set to 1 second. Okay, so this is like a timeout. So we can see this lifetime second, and this accept we can set to false. Okay, this is the key parameters. So here we can see this is different between this case and the previous video. In the previous video, the send and receive, we need two ports. But in this case, we only need one port. This is the beauty of this function block. Inside, this function block is doing send and receive that alternatively. So that's why they can use the one port. Okay. And here we can save. And we finish this setting. Once we power up the controller, let's firstly monitor this controller, verify the IP address. We can also monitor here, okay? So now let me download the controller. Okay, we download this controller and now it restart. And let's click this online monitor. And let's firstly verify the real parameter is running for this function block. Okay, so here we can click the monitor and we can change this to, this is the watch list. Okay, and we can change to decimal. Okay, we can see, so the target IP address is 192.168.1.253, and the target port number is 2000. Okay, and this PLC is running as a client. Okay, and the type is 1 IPv4, and this COM service we are running the TCP/IP protocol, TCP protocol. Okay, then the server side I will run a circuit test tool, use my PC running as TCP/IP server. Okay, I will paste the link under this video and you can download. This is the one tool for free. And in this case, we will run the TCP/IP server. And this is server IP address, like this case here, the server IP address is 192.168.1.253. Okay, and the port number, like a setting here, for the PLC is partner port is 2000. And the PLC side is 3000. Okay, and before I click the start listening, take care. If you are using your PC running as the server to do this test, make sure you shut down the Windows firewall. Okay, I will shut down my Windows firewall. Go to the Windows firewall and click turn off the Defender firewall temporarily. Okay, click OK. Don't forget, click OK. Okay. Turn off the firewall. Alright, now I can click this start listening. Now this server is waiting for the client to connect this server. And let's go to the OB1. So this server is still waiting for the call because so far we haven't enabled this function block yet. Okay, now if I toggle this enable this function block, and now it's keeping sending. And let's watch here. So is get this client from the server side 1.174. This is my PLC IP address. That means this function block is connecting with this server now. Okay, now it's nothing because we haven't sent or received anything. So now if I open this DB and let's expand this send and the receive buffer. Okay, send buffer and the receive buffer. To operate this easier, I will use this watch table. And I can drag this send buffer. Okay, I can drag this send buffer, the first 10 to here. And then drag 10 receive read buffer, 10 buffer data. They all bytes. Okay, so we can open this monitor watch list. And while we are sending the data to the PC, so actually is running the char. So I introduced before, so you can see the ASIC table. So we need to select the char right here. If we are going to send ABC, A, B, C here. So click this transfer, click this modify. So while we are sending the ABC behind, if we switch to the hex, it's sending 41. This is the ASIC. If you check the ASIC table, you will see the A represent the 41 hex. And in the meantime, because every 1 second we will send one time, so we will see it's keeping receiving this ABC. If meantime from the server side, we also try to send something XYZ W, for example, send. We will see it can receive the data at the same time. This is the beauty of using this LCom function block. The function block internally is organizing this send and receive automatically. So it's very easy to use. If we change to char, this is the data we sent. This is XYZ W. And if we change to QWERTYU, so send. So we'll see this command is there. Overwriting this table because it's keeping sending from the PLC, but we can see this QWERT. And let's try it again. 1, 2, 3, 4, 5, 6, 7. Okay, send, and very quick it receive. Okay, and in the meantime, if we change the data here, let's change to so X, Y, Z, JKL, J, K, L. Okay, once we transfer, and we can see the XYZ JKL is receiving. So sending and receiving, they can work at the same time. Actually, they are doing send and receive separately, but this function block can organize this very well. And here's one group feature I like to show. The reading buffer. While we defined this reading buffer, we define the maximum. That means it's a very huge buffer, it's a very long. So basically it can receive anything we try to send. If we just send a bunch of data here, we send, we can see it can receive. This receive length is dynamic. The reason why it can do the dynamic, in this function block, the receive function block is running as ad hoc mode. Analyze. If we go into this function block, all the code is open. So you can personally learn these things here. So this is the beauty of the Siemens function block. Most of the time, their function block is not sealed. So you can learn, or even you can troubleshoot what's going on there. So if we try to find the receive function block, we can see inside is using the TCOM, disconnection, send, and receive. And if we right click, select this, go to the next point of use, we will see this function block is calling here. And we can see this is the same topic we introduced in the previous video. It's active, this is a ad hoc. That allows this receive buffer can be dynamic. Okay? And this allows us the receive buffer is dynamic. And another thing I like to show, some cases you will find maybe a problem because this buffer is dynamic, and probably in some cases this buffer, if you have the new data, this buffer will not be override. They will be continuously. So For example, now if I expand here, so this is the receive buffer. Okay, no problem. Now if I send the 1, 2, 3, 4, 6, 7. Okay, we can see this data sent to here. Most of cases we like, because this data can overwrite every time this buffer represents the new data. But some cases when I tested this communication before, we will see some cases this new data will just be continuously. It will not overwrite the previous data. This is some design in this function block. I especially want to show this case. And if we scroll down, and there's one value is working that role. So if we go to this state receive, and there's one value named user data and offside. So this offside value is playing that role. So if we go down here, this is receive function block. If we go down, and if this NDR is true, so this case the data offside is 0. But if we cross-reference this offside, if we go down, and we will see this area, the offside data will be calculated by some codes here. And by some reason, your receive buffer will be continuously, will not override the previous data. This is the one of design from this function block. I'm now planning to diagnose or analyze the code why it causes this. But in case you have the problem on this, you'll find your data, new data will not override the old data. So the easy way is you force that user data, the offset value to 0. So how to force that? For example, if we go to the main, and let's drag the move command. And the target is that offset value. So we can go to this instant db1, open this, float, and we can force that state receive and user data and this offside. Okay, so we can force this offside. If now we monitor, so we'll see my case now is 0. In case you see this offside is not 0, we will find your data will not be override. For example, in this case, if I set this offside to 5, and now if I have a new data, you will see my new data will be start from the 5. If now I haven't downloaded the program yet, so if I set this offside to 5, so if now I send a new data, we'll see it now override 1, 2, 3, 4, 5. It will start from here basically. If I'm going to send OPQ, let's see. So we'll see the OPQ will start from here. And accidentally is override here is basically mess because this offside will not starting from the 0. So it will super confuse. Unless you go to the program, this function block, to digest what's going on, what it's doing. But easy case here, for this offside, we can set to 0. So to force to that to 0, so we can drag this offside, drag to here, and we can write 0 to this user offside. Okay, now we can download. Okay, this can guarantee your new data always override and your buffer always clean. So your new data always starting from here. For example, now I'm going to send 1, 2, 3, 4, 6. Send. Okay, 1, 2, 6. And now XYZ W JK. Okay, XYZ W JK. This is most of cases we need. Always override all data. Alright, this is how to use LCom and using Siemens S7-1200 PLC or 1500 PLC to do the TCP IP communication. As we can see, using this function block is much easier than using the tsend and the treceive respectively. And only little bit complicated things is you need to import the library and program the same way as I did and quickly review this parameter, and it doesn't have too much. Right? We only need to take care is this connection type and this COM service, and this target IP address is the port. Okay, and the server side, I'm using this software. Again, you can download this software under this video. It's very convenient. And personally, if I have one device need to communicate, 90% I will use this function block instead of using the tsend treceive the separate way, because this function block is much easier to use. Okay, this is the second method to do the TCP/IP communication. Thank you for watching.
Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.